Hello everyone, welcome to Skillease Academy. Thank you for registering for SQL Basic classes. Today we are going to cover a chapter on data types and constraints. Here we will understand the different basic data type we are going to use for building a SQL table and how to implement constraint. So before we start, let me just introduce myself. My name is Girish Kovilkar. I'll be your instructor for today. I have over 16 plus years of experience in data analytics, data engineering, data warehousing across various industry domains. Also, I have successfully led two data warehousing project implementation in my career span. Apart from this, I am also specialized in handling data, business process reorganization, and worked on technologies like SSIS, SSRS, Power BI, SQL Server, Azure Data Factory, Microsoft Fabric, and many more. You can find my career information on the LinkedIn link on the given screen. To start with, we will just see what we have covered in our last two sessions. We have seen the basics of SQL, how it got evolved, what standard it has, and how it is used. Then we have also seen the relational database. We have seen how the primary key foreign key concept works in the world of relational database. We have seen some of the functional area where relational databases are used. We have also seen multiple types of relations like one to many to one, many to many, and so on. To start with, let us see what we are going to do today. So first, we will understand what do you mean by the data types. Then we will do deep dive into why data types are important. Along with that, we will learn the different types of data type used. Then we will see the constraint. We will understand what do you mean by constraint in the context of database management system. Then we will see how those constraints helps us to build a data quality and data integrity throughout the database. We will also see some of the examples while doing each of these data types as well as constraint and also see some best practices and use cases. To start with, what do you mean by data type? So consider you have a box where you can store multiple items in that, like multiple glasses or multiple boxes inside that as well. Or you can have a biscuit, in that boxes presented over there. However, you cannot store a liquid in that boxes. So for liquid, what you have to do is you have to use either a bottle or a glass bottle, or you have to use some can or container. While if you have to store any kind of gaseous or mercury system, you need to store it in the cylindrical shape or compressed shape format. So similarly, in the SQL Server, we have data types. So data types is in SQL organize and stores different kinds of information, ensuring data like numbers, text, or dates are saved correctly. They make it easier to manage and analyze data while optimize storage and improve performance. Using right data types prevent issues like data loss or bad performance, which can happen if wrong data type is used. So what are the common data types used on the SQL side? So we have numeric data type. In the numeric, we have integer, float, and decimal. We have character data type where we store character or string or where char. We have datetime data type to store the date value or time value or a datetime combination value. Similarly, we have boolean as a data type to store the state of a record, whether it is active or not. We are going to deep dive this data type in upcoming slide. To start with, let us see the numeric data type. So the numeric data type, as the name suggests, stores the numeric values. First, we have an integer data type. So what do you mean by integer data type? Simply, integer is used to store whole number without any decimal values or any decimal points. Suitable for, whenever you have to do a counting of any item or indexing of any item or represent any of the ID. For example, we have product ID. It can it can be used to store as a product ID value. Similarly, we have float data type. So what does float data type means? It is used to store a decimal value where the decimal points are required to be stored in form of fractions. So the ideal use for this data type is for scientific calculation, measurements, or any scenario where precision is required but can tolerate some amount of approximation. Example, storing measurement like height or weight where precision is important. Similarly, we have fixed point number, which is a decimal. So decimal data type stores the number with fixed number of decimal places, providing exactness in the calculation. It is essential for financial calculation, pricing, or some scenarios where precision is critical and rounding off error are unacceptable. For example, we normally store price of a product in a financial application to ensure accurate billing using decimal data type. So here is an example of a product table. So what we have done is product ID is defined as an integer where price is defined as a decimal 10, 2. So in the product ID column, we can only store the product ID of a product in a whole number format. Second, in the price column, we can store the price of a product up to 10 digit, including 2 digit as a decimal places. So, for example, we have 800.99. We cannot store 999 or 992. We can store up to 2 decimal places. So, this is with respect to numeric data type. Now, let us see with respect to character data type. So, in character data type, we have char as a character data type to store any fixed length character string. So, string is nothing but a series of character or series of alphabet, you know, merged together into a string, like a name of a person. It can be a string or any comments you see on the YouTube or a Facebook. Those comments are stored as a string. So what exactly the character data type specify? Whenever you specify character data type with the length of a character, it stores those number of character in that. For example, if you create a character data type with char of 10, it can store up to 10 characters, which is 10 alphabet or alphanumeric characters, or any special symbols as well. So when you create char of 10, what happens is if you have a name with just Sam, so you have SAM, only 3 characters are used, while rest of 7 character of the field are stored as a blank spaces. So irrespective of the value of the column, it is utilizing all the 10 spaces or all the 10 characters for that column. So where can we use the character data type? It is ideal for storing value where you know the specific length of a character, length of a string, consistent, such as country code or any fixed length identifier like a phone number. It cannot be exceed more than 10 digit or 12 digit. Similarly, what we have next is a varchar, which is a variable length string. Let's say, for example, you have decided to create a varchar of 20, whereas you define the name of a person as a Sam, which utilize only 3 characters. So it only uses 4 bytes of memory, which is S, A, M, and then the length of the particular string. So it is ideal to use whenever you are not sure about the exact length of the string. For example, name, email address, or other such text data where the length is not constant. At that point of time, you have to use varchar. Here is an example of a customer table where first name and last name are specified as varchar 50, varchar 50, whereas country code specifies as char 3. So what happens when a first name is has only 5 characters? So it will not store any values or any additional spaces appending to the first 5 characters. Here, the optimum use of space is done. Now, let us see a next data type. So here we have a date time data type where we have 3 types. We can store a date, we can store a time, or we can store a date time together. So why do you need date, time, and date time? It depends on the scenario. Say, for example, you want to store a birth date of a person or a due date of a particular bill. At that point of time, you will not require to store the time. Whereas, whenever you have to schedule an appointment or a particular event, at that point of time, you might to need both date and time. Hence, we have date, time, and date time. Date can be stored as dd-mm-yyyy, or in this example, we have stored it as yyyy-mm-dd. Similarly, the time is stored in it is stored in hh:/mm:/ss, or it can be also stored in hh:/mm, where the seconds are not needed to be stored. Similarly, if there is a scenario where you need a milliseconds, so you can store it as hh:/mm:/ss dot t. So t stand for the timestamp of the remaining milliseconds. Similarly, we have a third date time data type as datetime. So you will be surprised that why we have three. There are some cases where both date and time are required. In that particular case, instead of having two separate columns, we have only one single column. It is used for recording complete timestamp detail, such as if we want to store a transaction time or if we want to store any log entries. At that point of time, we use date time. Here is an example of an order table. So to simplify, we have just created order date as an date data type, order time as an time data type. Also, we have order date time, which is a date time data type. So depending on your need, you can define the column accordingly. Now, third, we have Boolean as a data type. So in the Boolean, we can store either true or false. Why do we need a Boolean data type? It is used to represent a truth value of a particular row. For example, we have an user table where we need to define whether that particular user is active or not. So instead of saying it as active or A or I as an inactive, we just store a flag called Boolean. At the backend, it stores the data in a bit. So bit is nothing but a smallest storage space in the computer system. So how do you define what data type to use? Depending upon your need or depending upon the optimization you want, you should use the data type. For example, here, if we use A or I, it will use at least 8 bit, whereas we are using only 1 bit. So it is 1/8 of space is saved. If you think on a larger database, each bit utilized in the database is very important. Also, if we have to sort or filter using the Boolean instead of character or varchar, it is much more faster. So what are the other common examples where this Boolean data type can be used? Whenever we have to initialize a transaction as a default active, we can set it as 1. It is in the backend, it is stored as zeros and 1 to represent a bit value in the storage system. Now, let us see the next topic, which is constraint. So, what do you mean by constraint? These are a rule applied to the database column to enforce data integrity, accuracy, and reliability. Why the constraints are so important? It is because they ensure only valid data is entered to the database. It prevents inconsistent or corrupt data by restricting the type, the range, and the uniqueness of the data. So, what are the different data types of constraint? We have not null constraint, we have unique constraint, we have primary key constraint, foreign key constraint, we have check constraint, At last, we have a default constraint. Now, let us see one by one on this constraint in the upcoming slide. First, not null constraint. As the name suggests, not null constraint create a rule on a specified column to not store any null value. This guarantee that a column must always have a value. It is required for a data integrity such that always accurate or always a valid value is provided or any incompleteness of record is not there. It maintains consistency across database entries by enforcing mandatory field. So, how do you define a not null constraint? So, here is an example. If you see, we are creating an employee table with employee ID and employee name, whereas employee ID is an integer data type with not null. So, whenever you're creating an employee in an employee table, it has to specify a valid integer value. Otherwise, it will fail the statement or the database system will give you a specific error to that particular constraint. Similarly, when you enter a name without any value or just without passing any value in the name column, it will give you an error. Some tips are whenever you have to specify a mandatory field in your front end form. So, whenever you are filling any Google form or any application form online, they have written as a asterisk to the field name, like a name or an address, which is mandatory, or a phone number, which is mandatory. At that point of time, you have to specify some value to that particular row. Similarly, in this, to handle this on the database side, we have to create the constraint on that particular column. This will help the data quality to maintain and prevent of storing incomplete value. Similarly, we should always consider which fields are essential for your database integrity and apply not null constraint accordingly to enforce the requirement of that column. Next, we have unique constraint. As the name suggests, unique constraint ensures that each value specified for the column for the different rows in the table are uniquely present. This is used to enforce uniqueness at the column level, preventing any duplicate entry. In this example, we are seeing the user table is created with an email address as an unique constraint. So, what happens if you try to duplicate the email address if it is existing in the table? The database system will throw an error and stop that particular insertion or updation of the record. Some of the use cases for this particular constraint are username, where you want to create a unique username for each login, or ID. We need to create a unique IDs, or any other unique identifier where you need a unique values to be present for that particular column. Next, we have a primary key constraint. So primary constraints are uniquely identify each record in the table. It ensures that column or a combination of column defined as a primary key has unique value for each row of that table. Also, they does not accept any null values. So, if you see primary key constraint and unique key constraint are almost the similar. However, unique key can allow at least one null value, whereas primary key does not allow a null value. Hence, primary key can be also defined as a combination of not null and unique key constraint. So, where do you use an primary key? In this example, we are creating a primary key on the department table, where department ID is specified as a primary key, whereas no other department will have same key as an identifier of that department name. So some of the use cases of primary key is identifier, or whenever you have to create a referential integrity. At that, that point of time, what you have to do is you have to define a primary key on a parent table column, and that primary key then only can be referred as a foreign key in the child table. So let us see the foreign key constraint. As the name suggests, foreign key, it is referred to a key of a primary keys table. It helps to link the two tables together. It ensures that whatever value you are trying to insert in the child table is already exist in the parent table. This maintains the integrity of the data, ensuring the relationship is valid. So we have an order table where we need to know that which customer has placed the order. For that, what we have done is we have created a customer ID inside that order table. Along with that, we have created a primary key constraint on the customer ID. So we have created primary key constraint on this customer ID from this table, which refers the customer ID of a customer table, whereas customer ID is defined as a primary key of a customer table. So there are some examples to be remembered, like whenever you're defining any parent-child relationship, for example, order header or an order detail, or employee is linked to the department. At that point of time, you have to use primary key and foreign key to maintain the referential integrity. There are some common notes to be ensure that whenever you are deleting any values from the primary key table, if it is referred in the child table, what happens is you have to either define a cascading effect or cascading action of it, saying that whenever the key is deleted in the parent table, the child table record is also deleted. Or whenever it is updated, it is also updated. If nothing is provided, what happens is whenever you try to delete any record in the parent table, it will throws an error saying that this particular value of customer ID is used inside the order table. It is also used for indexing. So, whenever you are creating an index, you have to create on the foreign key and the primary key. It will help you to improve your query performance whenever you are dealing with a large set of database or a tables. Next, we have a check constraint. So, the check constraint is used to limit the value range that can be placed in the column. If you define a check constraint on a column, it allows only certain values to be present or validated. For example, whenever you are defining a price of a product, it cannot be less than 0 or equal to 0. So, what we have done over here, we have created a product table with a check constraint on the price, where the price should be always greater than 0. So, what happens if you enter any price which is either less than 0 or equal to 0? It will throw an error. It will say that price should be at least greater than 0. Sometimes you can also specify that a price should be at least $5. So accordingly, the check constraint will work on the system. Some of the key points for the check constraint. Check constraint ensure that only valid data that meets the specific condition to be entered in the column. In this case, it ensures that the price of a product is always positive. Similarly, by enforcing this condition, the check constraints helps to maintain the integrity and correctness of the data in the database. It prevents invalid data entry that could cause issue while processing for analysis. Some of the use cases would be ensuring that the value entered in the column meets specific criteria. Some can be have a business rule, like it will have the value A for active, I for inactive, or P for processing. You can also define multiple check constraints for a table to enforce various conditions on different columns. Check constraint can include complex conditions involving multiple columns, logical operators, and functions. Not all database management systems enforce check constraint in the same way. So, it is important to test their behavior across different systems if you are using multiple database management systems. So, these are the important tips we need to keep in mind. Next, we have a default constraint. By the name suggests, default constraint is used whenever no value is specified to the column while insertion. For example, whenever you are doing a customer registration, a registration date, if not provided, it will automatically take the current date of the database server. So by default, what happens whenever you specify any values to the column, it will override the default constraint and store the value. So for example, if you want to specify a registration date while registering a customer as of yesterday, you can specify that date while doing the insertion. So automatically Instead of having a current date, it will store yesterday's date as an registration date. Some of the key points to remember is whenever a default constraint is used, by default, it sets the value to the column if no value is specified. It is also used for automatic timestamping. It is used to have a default status whenever an initial stage of a process has to be active or has to be initiated state. It assigns the value automatically. Some column also have initial values as 0. That also can be defined in the default constraint. There is a common note for this constraint is it can be constant or a function call. It can be overridden by a value during the insertion. So here comes with the conclusion of today's lesson. What we have covered is importance of data type and the constraint. We have seen different types of data type. We have seen different types of constraints. We have seen some examples and best practices and so on. So for the reference, we have provided the list of books which you can refer and increase your knowledge on the SQL side. Similarly, specific to this topic, there are some links on the official site of MySQL for data types and constraints specific to MySQL database. Similarly, for Postgres database, you will find the link on the Postgres sites. So now we are open for the question and answer if you have. Or what you can do is you can email your questions or queries on inquiry@skilleaseacademy.com. You can also comment your questions on this page. Thank you. See you in the next class.